So also in the 6364 units, all right, there's going to be these average value problems. So I'm just going to do a couple here just to kind of give you the idea, right? And so you may remember we did mean value theorem for derivatives. Well, this is kind of the mean value theorem of integrals, okay? So find the average value of the function over the interval. Okay, so if we have this, one of the ways we can do this is we can find the total area, right, for ourselves under the whole thing. So we could do the 2x plus 1 from -3 to 1 dx, okay? And that's going to tell us what the area is. Well, the antiderivative of that is x squared, and the antiderivative of that is x, okay? And then we'll plug in from 1 to -3. So f of 1 is 2, f of -3 is 9 minus 3 is 6, okay? So the area is -4 for ourselves, 2 minus the 6. Okay, so the area is -4. So that means that basically this is this shape has an area of -4, right? And it gets that area of -4 over this length of the interval, right? This over here, the change in the x is 4. 1 minus -3, so it's 4. So the area is -4 over a length of 4. So the average value is just going to be, you take those two and divide them, and that's -1. So that's basically saying, if my height was -1 the entire way for this unit, for this length of 4, right, then that would, I'd have the same area as what I have there, right? So there's a different way to figure out this. I'm figuring out the average value of this of the function over the interval. Okay, so if I was going to do number 3 here, right, I start by calculating the area, which is x squared minus 2x, right, antiderivative, right? Okay. And hopefully you've done all those antiderivative problems. Okay, so I'm going to find this area. So I'm going to do f of 3, which is 9 minus 6, or 3. F of -1, which is 1 plus 2, which is 3. Okay, 3 minus 3. So the area there is 0. Okay, so 0 divided by the length of the interval. The length of the interval is 3 minus -1 is 4. That's our change in the x. Right. So our average value is 0 there. Okay. Now this can be summed up with this formula. You basically take the integral from a to b of your function, and then divide by b minus a. So this says find the area from a to b, and then this is right here is the change in excuse me, change in x for ourselves, and that's going to be my average value. That's my formula. Right, and so this worksheet's going to be basically doing that over and over again. Right, let me do one where there's a square root, even though it's really the same thing. Okay, so add 1, so it's 3/2. Because it's a fraction, it's kind of hard sometimes to figure out what the coefficient is going to be. So I just go by the, the way that always works is always divide by that new power. Okay. This is going to become 8/3 dividing by 3/2, same thing as multiplying by 2/3. Okay, f of 3 is 3 to the 3/2 power. F of 0 is 0, right? And hold on. So we have the upper and the lower bounds, so that's a really messy number. I don't love that one, but so 8/3, right? Oh gosh, so let's see, that's the square root of 27. So I'll just leave it that way. The length of the interval is 3 for me. Well, if I reduce that, that's 3√3. Oh, that kind of cancels out. That's nice. So I get 8√3 over 3, so there's my area. And I don't know, let's take a look at the answers to this packet, see what it says, how they're going to leave it. Well, if it's a decimal or a fraction, right, what does it want? I think it gives you both. It gives you both the radical or the decimal, so you kind of do whatever you want there. Okay, so you just kind of go through these, and there's just, it's the same process for everyone. You just have to find those antiderivatives. So this week is a lot about just practicing finding antiderivatives. Tons of practice on that. All right, so we can do what we need to do next. Okay. let's see. So if we do some later problems, let's look at a later problem here. Right? A later problem would be something like 25. Okay. All right. So if we're going to look at 25 here, okay, for ourselves, find each problem. For each problem, find the average value, then find the values of C that satisfy the mean value theorem of integrals. Okay, so this starts the same way. I'm going to write this as 2x to the negative 2. Okay, so I'm going to add 1. Okay. Oh, look at that negative. Remember, we can just take this negative and tuck it in here and flip the bounds. That makes it easier. So f of 2 equals negative 1, and f of negative 5 equals negative 2/5. So I'm going to do negative 1 minus negative 2/5. So I get negative 3/5. So that's the area under the curve. Now, how long is the interval? Let's see, negative 2 minus negative 5 has a length of 3, so I'm going to take that and divide by 3, which gives me negative 1/5. Okay, so that's the average value. Okay, and then find the values of C that satisfy this. Okay, that just means set it equal to it. Right? And we actually take this x and we write it as a C when we do that. Okay. And then we solve for C squared in this case here. So I'm going to multiply, cross multiply, so I get negative C squared equals 10. C squared equals negative 10. All right. Let me just double check. Did everything I needed to right here. Okay, because this would say that there are no values that satisfy it, which would be an issue, all right, because there have to be values. So let me just double check. Oh, found my mistake. I wrote this backwards at the beginning. This was negative 5 and that was negative 2. So negative 2 and negative 5. Right, everything was backwards here. Okay, so these were backwards. That became that plus. That's plus. Okay, now we're all set. I knew it had to be wrong because I had to have an answer. So C is plus or minus the square root of root 10. Right, now it has to be within this interval, so that's going to mean it's just negative root 10. And you may remember from the mean value theorem for derivatives that we have to lie in the interval, so we get rid of root 10 because it's not between negative 5 and negative 2. Okay, so that's how we do those examples. Let's do another one. All right, let's try 26 here. So find the average value. And so the antiderivative, that's going to be x cubed. That's going to be x squared, okay. It's going to be 2x squared, because 2 times 2 is 4, plus 2x, okay. Do that from 0 to 3. So let's find f of 3. F of 3, let's see, if I plug it in here, that's going to be 27, so that's going to be negative 18. Right here, it's going to be 9 plus 18. Plus 6, okay, so it's going to cancel out. F of 0, oh, it's going to be nice, it's going to be 0. So 6 minus 0 is 6. How long is my interval? 3 minus 0 is 3, so that's my change in x. So it's 2 for my average value. Okay, so we have our average value, and then let's set this average value equal to the original function. Oops, I should put C in there. It's not that big a deal if you leave the x in there. It's really not a big deal. All right, let's see, I'm going to move something around. Oh, those are going to cancel. I'm going to factor to solve this, so I'll factor out the negative 2c. Okay, that's what I get. So c equals 0 and 2, both of which are in the interval. So that's the both times. So there's 2 answers for that one there. Right? We get 2 answers. Sorry, that was going to drop below. Okay. So these ones are the same thing with getting those average values, but you just get those. You get the values of C afterwards. Okay. Right, so those are they just get, just keep working on those and trying all those. Oh, there's only one left of the average values because I did 2 of them. All right, so you can do the average. There's only one left in that section here, but the rest are pretty much the same. So good luck on those problems. Stop by office hours if you need help, or email me if you have questions.